Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 29th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 29, Distinct Powers. Consider all integer combinations of a to the b for 2 less than or equal to a less than or equal to 5, and 2 less than or equal to b less than or equal to 5. 2 squared, 4, 2 cubed, 8, 2 to the 4, 16, 2 to the 5, 32, etc. If they are then placed in numerical order with any repeats removed, we get the following sequence of 15 distinct terms. I'm not reading all of those. How many distinct terms are in the sequence generated by a to the b for 2 less than or equal to a less than or equal to 100, and 2 less than or equal to b less than or equal to 100? So, in Java, this would be a pretty simple thing, because in Java we have a set. I'm not sure if there's something really equivalent in Python. However, Python does have something called a dictionary, and the keys have to be distinct, so we can use it in the same way, and that's my plan. Because the easiest way to do this, the trivial way, would be to just go through, calculate all those numbers, and count how many distinct ones there are. So first we make sure we have our problem statement up at the top here, where it's convenient. And then we go copy our date time stuff, as I do every single time. And I'm going to keep using this limit. This time it's 100. Because why not? That stands us in good stead if, for instance, there's another problem later that is similar, except it's 1000 instead of 100 or whatever. And then what I am going to do is have a terms dictionary, and then very simply for I in range 2 limit plus 1, for j in range 2 limit plus 1, result equals I to the j terms dot, what is it? Is there a I think I can just do that. I'm just gonna say 0. And then if I print, length of terms. Okay, so all I'm doing here is I created a dictionary. I am iterating through 2 through 100. And for every I in that range, there's also going to be a j in the same range, I to the power of j, and then that result I'm just putting into the dictionary. So this should be the correct answer. Let's see how efficiently it runs. What are we at? I already forgot what problem we're working on today. It's 29. Okay, so it gave us this number of 9,183 in, what is that? Less than 1/100th of a second. Let's see if that is the correct answer. I always forget to refresh the page. And that is it. So, short and sweet for today. There are maybe some languages where this would not be quite so rapid. If you had to if you were trying to just count, I think that would be very difficult. But because we can use this, like, data structure to just automatically ignore duplicates and then just say, how long is our data structure? It's really, really simple. So, easy peasy, correct answer first try. And it was way, way, way under our 1 minute time limit. So, I'm going to call it there for today. And I'll catch you in the next one.